Anthony Raj. He has pursued his bachelor's, master's, and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idya Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Material Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series BArch Mathematics Semester 1 Lecture 8. In this lecture, we are going to see about integration. In integration of a rational function, integration of trigonometric function, integration of irrational functions, then properties of definite integrals. These are all the concepts we are going to see in this lecture. Integration of rational and irrational functions. You know, integration is a mathematical technique used to find the length of a line if we know the starting point and end point of a line, and the same integration technique can be used to find the area under a curve if it is a double integral. Then using integration you can find the volume of a solid if that solid is integrated 3 times. That is, using triple integral we can find the volume of a solid. These are all some of the physical application of the mathematic technique integration. Here in this lecture we are going to see how to integrate a rational function. For that, first we need to know what is rational function. You know, rational function is the one which is the quotient of 2 polynomials. That is, if 2 polynomial functions are expressed in ratio, then that expression is called rational function. Here some of the examples are given for rational function, like 1 by 1 minus x square is a rational function. Here 1 is a polynomial and 1 minus x square is also a polynomial. Then x cube by 1 plus x square. Here the numerator x cube is a polynomial of order 3, and 1 plus x square, the denominator, is a polynomial of order 2. So this is also a rational function. Then a complex rational function is given here, that is 5x cube minus 3x square plus 15x minus square root of 2 over x power 5 plus 2x square plus 1 is a rational function which is a bit complex. So these are all examples of rational function. So now you learnt what is known as rational function. Now let us get into the integration technique of this rational function. You know, in the definition of that rational function, we have in C the square root of x and neither logarithm of x or the magnitude of x. Then the rational function can also be differentiated or classified as proper rational function and improper rational function. A proper rational function is the one if the degree of the numerator is lesser than the degree of the denominator. Otherwise, that rational function is called as improper one. That is, if the degree of the numerator is less than the degree of the denominator, the rational function is called as proper rational function. If the degree of the numerator is greater than the degree of the denominator, such rational function is called improper rational function. This is how rational functions are classified as proper rational function and improper rational function. Now let us come to the indefinite integrals of the rational function. Indefinite integrals of the rational function can be accomplished any of the following method listed here, that is polynomial division method, partial function expansion method, term by term integration method. These three methods are prominently used to integrate the rational function. Collectively, we shall classify the integration of rational and irrational function into the following types. Type 1. Suppose the given rational function is in the form of dx by quadratic, or the rational function is dx by square root of quadratic. You know, quadratic equation, the general form of quadratic equation is ax square plus bx plus c is the general form of quadratic equation. If that quadratic equation exists in the denominator of a rational function, or square root of that quadratic function exists in the denominator of the rational function, how it can be integrated? That comes under the type 1 integration of rational function. To do the above said integration, some 3 steps need to be followed. First step is make the coefficient of x square unity by taking its numerical coefficient outside. You know, in a quadratic equation or in a quadratic function, in general, a is the coefficient. In the first step, to integrate the rational function which has quadratic in the denominator, we need to make the coefficient of x square unity. That can be done by taking its numerical coefficient outside. Then the second step is complete the square in terms of x by adding and subtracting the coefficient of x over 2 the whole square. That means the coefficient of x over 2, the half of the coefficient of x in a quadratic equation or function, in general b is the coefficient of x. So let us take half the value of that coefficient, it will be b by 2, then square it, then add and subtract the given obtained value to complete the square. This is the second step. We need to do an integration in the type 1. Then we will get the required integrand in simplified form. Then we can apply a proper standard form of integration to complete the integration. This is the thing about type 1 of rational function. Then type 2 rational function, that means kind 2 of rational function. This function will be in the form of linear over quadratic. You know, linear means ax plus b is the general expression for a linear equation. Quadratic, ax square plus bx plus c is a quadratic equation. If the given rational function is in the form of linear over quadratic, or linear over square root of quadratic, or linear into square root of quadratic, in any of these form you can adapt the following step. So I will give an example for this linear over quadratic first, then I will go to the steps. This px plus q over ax square plus bx plus c is an example for linear over quadratic kind of rational function. Then linear over square root of quadratic, px plus q over square root of ax square plus bx plus c is an example for the kind linear over square root of quadratic. This is linear into square root of quadratic, px plus q into square root of ax square plus bx plus x dx is the example for linear into square root of quadratic. This kind of rational function can be solved in 3 steps. First step, we need to make linear as derivative of quadratic by substituting linear is equal to a into derivative of that quadratic with respect to x plus b. So this is the first step we need to do to solve or to integrate rationals like linear over quadratic. Then the second step is equate the coefficients of x and constant term to obtain the value of a and b in the previous step. Then replace the linear part of the problem by step 1 and then use the standard integral. We will get the result of the integration of rational function of the kind linear over quadratic. Let us go to the third kind of rational function. The third kind of or third type of rational function is dx by linear into square root of linear. Here this L stands for linear and Q stands for quadratic. So the third type is of the form dx over linear into square root of linear, or linear into square root of linear, or linear over quadratic, already we have seen this, or linear over square root of quadratic, this also we have seen in the earlier step, or linear square root of linear. So in any of these four forms the given rational function exists means that comes under type 3 rational function. In this case we need to substitute, we need to adapt a substitution method to do this. That is, the square root of linear need to be substituted as L is equal to Z square. So automatically this square root of L will become Z, and here L already, as I said earlier, L stands for linear algebraic function and Q stands for quadratic polynomial. So if you get a rational function of this form, it can be integrated. Then rational function of type 4, dx by linear into square root of quadratic. In this case substitute square root of quadratic is equal to z, or x is equal to 1 by z. Then type 5, dx over quadratic into square root of quadratic. The given rational function is of this form. In this case also you substitute linear is equal to 1 by z, then adapt the standard integration method, we will get the solution of the given integration of the given rational function. So like this the given rational function can be classified into 5 types and the steps can be used to integrate the rational function. Now we will apply these concepts in a problem. The given problem is evaluate the value of dx over 3x square plus 6x plus 5. So this comes under 1 by quadratic. This comes under the form 1 by quadratic. Let us see how the solution to this integration can be obtained. Solution to this integration can be obtained by taking this given integration. The given integration is integral of dx over 3x square plus 6x plus 5. Now manipulate this, and that the first step we need to do is we need to take the coefficient of x square out. So if you take the coefficient of x square out, the given rational function will become integral of dx over x square plus 2x plus 5 by 3. So this is the first step we need to do. We did this. Next let us take the denominator. The denominator in this integral is x square plus 2x plus 5 by 3. Now manipulate this denominator. Need to express this in square form so that you add and subtract 1 with this quadratic. So x square plus 2x plus 1 plus 5 by 3 minus 1. So with the above step, we just added one 1 and subtracted 1. So the value of the quadratic expression will not change. Now this can be clubbed, that is x square plus 2x plus 1 can be clubbed. This is in the form of a square plus 2ab plus b square. So this is in the form of that expression, plus 5 by 3 minus 1 gives 2 by 3. So instead of this x square plus 2x plus 1, we can substitute x plus 1 the whole square plus 2 by 3. Now take this and substitute. So we manipulated the denominator or simplified the denominator. Substitute this denominator in the given integration. So the integration will become 1 by 3. This 3 came by taking the coefficient of x square out. Integral of dx over x plus 1 the whole square plus 2 by 3. So this can be further manipulated as this is in the form of x square. This 2 by 3 can also be expressed as the whole square. How that can be done is dx over x plus 1 the whole square plus the square root of 2 by 3 the whole square. Square root of 2 by 3 the whole square. This is in the form of integral of dx over x square plus a square in this form. So we have reduced the given rational function to a standard integral form. Now we can apply the formula for the standard integral form. The formula for the standard integral form is 1 by 3 into tan inverse of 1 by 3 into integral of dx by 3x square plus 6x plus 5. So this is the case, which is equal to 1 by 3 comes as it is into root 3 by 2 into tan inverse of x plus 1 over root 2 by root 3 plus c. So this integral of dx over x square plus a square is equal to a into tan inverse of x by a, x by a. So the result of this integration is 1 by root 6 into tan inverse of root 3 by root 2 into x plus 1 plus c is the result of the given rational function integral of dx by 3x square plus 6x plus 5. So from this example we learnt that the coefficient of x should be taken out first, then the remaining denominator is to be manipulated to get the standard form, then it is substituted in the given integral. We got the final result as 1 by square root x into tan inverse of root 3 by root 2 into x plus 1 plus c. Let us go to a second example which is in the form evaluate integral of 1 plus sin x cos x over square root of sin square x minus 2 sin x minus 3. Here trigonometric functions are involved. So by solving this problem you can understand the integration of trigonometric function. In this integration the trigonometric function is expressed in the form of quadratic, that is sin square x minus 2 sin x minus 3, that's a quadratic form. Then 1 plus sin x into cos x, that's a linear form. So in general algebraic case, this integration can be considered as a linear over square root of quadratic. In trigonometric case, this integration can be considered as an integration involving trigonometric function. Now let us come to the solution of this integration. Solution to this integration is by substitution. First substitute sin x is equal to z. Substitute sin x is equal to z. Then find the value of dz. So dz is equal to cos x into dx. Now after substituting these assumption in the above integral will change into integral of 1 plus z over square root of this sin x is equal to z, so z square minus 2 into sin x is z minus 3, z square minus 2z minus 3 into dz, because the cos x dx can be here a dx will come in the problem. So cos x dx, instead of this cos x dx, the dz can be substituted. Now we change the integral to a form linear over square root of quadratic. Now again do a substitution, method of substitution. Substitute 1 plus z is equal to a into d by dz of z square minus 2z minus 3 plus b. So this we learned this step in type 2. So this is we need to do, that is 1 plus z is equal to a into differentiation of this quadratic. Differentiation of this quadratic gives 2z minus 2 plus b, 2z minus 2 plus b. Now equating the coefficients of z and the constant term, we will get a is equal to 1 by 2 and minus 2a plus b is equal to 1. Therefore b is equal to 2. So we got the value of b and a after equating the coefficients of z and the constant term. Now substitute these values in the given integral. Therefore the integral d1 plus z into dz over square root of z square minus 2z minus 3 will become 1 by 2 into 2z minus 2 plus 2 over square root of z square minus 2z minus 3. So this need to be integrated. To integrate this, above integration will proceed like this: 1 by 2 integral of 2z minus 2 over square root of z square minus 2z minus 3 plus 2 integral of dz over square root of z square minus 2z minus 3, which is equal to 1 by 2 into square root of z square minus 2z minus 3 plus 2 into integral of dz over z minus 1 the whole square minus 4, square root of z minus 1 the whole square minus 4. Further simplification of the above step gives 1 by 2 into square root of z square minus 2z minus 3 plus 2 into log of z minus 1 plus square root of z square minus 2z minus 3. plus c. So this is the value. This is in the form of integral of x 1 by square root of x square minus a square. So in this case log x plus that expansion will come. So this is the case. It is equal to 1 by 2 square root of sin square x minus 2 sin x, that is the value of z is substituted in the final expression, minus 3 plus 2 into log of sin x minus 1 plus square root of sin square x minus 2 sin x minus 3 plus c is the final expression of the integration. So here in this problem we learnt how to integrate a rational function involving trigonometric function. So the final result is in the form of 1 by 2 square root of sin square x minus 2 sin x minus 3 plus 2 into log of sin x minus 1 plus square root of sin square x minus 2 sin x minus 3 plus c. So where this c is the constant of integration. So this is the thing about integration of trigonometric function. Next we will move to integration by parts. We will move to properties of definite integrals. You know, indefinite integrals does not have limit. Definite integrals have limit. Here some 4 properties are listed for definite integral. Integration between a to b of function f of x dx is equal to minus integration between b to a f of x dx. In the first property, if you change the limit, minus sign will come. Second property, integration between a to b f of x dx is equal to integration between a to b f of u dx. Here change of variable is used. Third property, integration between 0 to a f of x dx is equal to integration between 0 to a f of a minus x dx. Then integration between a to b f of x dx is equal to integration between a to b f of a plus b minus x dx. These are the 4 properties of definite integral. Summary. In this lecture, we learnt about the integration of rational and irrational functions, then trigonometric functions, then integration of some properties of definite integral. We learnt that rational function is the one which is the quotient of 2 polynomials. This rational and irrational function can be integrated using various techniques, and we classified the rational function into 4 kinds, and we adapted various steps. Then partial fraction expression is one of the technique to perform integration of rational function. After listening to this lecture, you can answer the following questions. Define rational function, evaluate integration of dx over x into x power 5 plus 1, list the properties of definite integrals. These questions can be answered. Thank you.